This is the first of two videos on algebraic fractions. In this video we're going to look at simplifying by cancelling and factoring, then we're going to go on to addition and subtraction, and in the next video we will look at multiplication and division. So let's start off. We're asked to simplify fully x squared divided by x. If you like, you can use the rules of indices, or you can simply think of this now as x multiplied by x over x. If we have this scenario, we can cancel an x in the numerator and an x in the denominator. So this simply becomes x. So that is fully simplified. If you want to see this as the rules of indices, we know that x to the power of m divided by x to the power of n will be equal to x to the power of m minus n. So you're subtracting the powers. So we end up with now just x to the first power. In the next one, we're asked to simplify fully 3x cubed over 6x. So this time we have numbers, and also we have now x cubed and x. If we think the 3 and the 6 are going to cancel, the highest common factor is 3, so that will give me 1 in the numerator, and I'm just going to write it as 1 to begin with, and then we would have 2 in the denominator. X cubed divided by x is going to give me x squared, so I could simply write this now as x squared over 2. So I'm just cancelling off. If you wanted to think about this now, this is going to be 3 multiplied by x, multiplied by x, multiplied by x, over now 2 times by 3 multiplied by x. We can see that the 3's are going to cancel. We will have now one of the x's cancel, and that simply leaves us now x squared over 2. This isn't an efficient method of doing it, as when it gets quite large in terms of the powers or these values right here, we simply need to use either the rules of indices or just work through on a bit of logic. And with your numbers, again, if they're large, just think, what is this one divided by that one? Okay, let's have a look now. We're asked to simplify fully 10x squared y squared over 5x to the fourth y. We've got y, so that's just y to the first power. I know that 10 divided by 5 is going to give me 2. I've now got in the numerator x squared divided by x to the power of 4. That means that the x squared will cancel in the numerator, leaving me x squared in the denominator. If you want to think about that now as the following, if we have x squared divided by x to the power of 4, we subtract the powers, which gives us x to the minus 2, which is 1 over x squared. Entirely up to you on how you want to view that. Y squared divided by y will simply give me y. So this is fully simplified. It's 2y over x squared. This one here, we're asked to simplify fully x squared plus 2x over 3x. If we look at the numerator here, we have a common factor of x. What I'm going to do here is factor this. We'll have x multiplied by x plus 2, and that will be divided by 3x. We can see now that the x's are common, they will cancel, so we can simply say that this is going to be x plus 2 over 3. So let's just tidy that numerator up, then we'll have x plus 2 over 3. So let's go ahead now and put that in. Whilst we're here, I think it's hugely important to look at the following thing. If we have x plus 3 over 3, don't be tempted to cancel the 3's and just write it as x. This is a common error, and that's put does not equal 2. Now if we think about this, if we said that x was equal to 10, and we look at this, 10 plus 3 is 13 over 3 doesn't equal 10. So don't fall into that trap. We can factor and cancel, but we can't cancel if we have this addition or a subtraction sign between the two values. In this one, we're asked to simplify fully. Again, we have a common factor of x in the numerator, so that's going to give me x multiplied by x minus 5. In the denominator, we have what we call a linear factor, and that's x minus 5. If we have x minus 5 and x minus 5, these will cancel. They are like terms. So this just leaves us now with x. So that is my final answer. It's simply x. Once we can factor it, we can go ahead and write it like so. So this is an example of factoring and then cancelling. Okay, let's have a look at this one. Can we do anything with this one? Well, x is common in the numerator, and that would leave me now x, 3 minus x. In the denominator, we've got a common factor of 2. So that would be now 2, and we'd have 3 minus x. So let's check we factored this correctly. 3x minus x squared, we can write now as x, 3 minus x, and 6 minus 2x can be written like so. We can see that these are common, and that's simply going to give us now x over 2, or 1/2 x. In the next one, we have now a quadratic factor. This is in the form ax squared plus bx plus c, so we can look to factor it. We need two numbers that multiply to give minus 6 and add to give minus 1. There's some clue in the denominator. I can write this as x minus 3, and then we'll have x plus 2. That gives me the numerator. The denominator is going to be x minus 3. We can cancel the x minus 3's, and that's simply going to leave us x plus 2. So our final answer, you could put this over 1. Generally speaking though, we would write it as x plus 2. I've factored the quadratic expression here and simply gone ahead and cancelled off the x minus 3's. On the next one, we're asked to simplify fully. So something similar. So I know that that numerator will factor. So that's x minus 3, and then we're going to have x plus 2. We also have a quadratic expression in the denominator, and it's in the correct form. Ax squared plus bx plus c, two numbers that multiply to give minus 12 and add to give 1. That looks to be x minus 3 and x plus 4. Let's check that. We're going to have x squared minus x plus 4x minus 12. We can now cancel the x minus 3's, and that's going to leave us now x plus 2 over x plus 4. Sometimes you'll see in books they're written in brackets, sometimes they're not. At this stage, don't do anything crazy. Don't go ahead and do the following. For example, another common misconception, well, there's an x there and an x there, so we'll cancel this, which is going to leave me 2 over 4, which is going to leave me 1/2. That is not correct, okay? If we think about this now, if we think, let's say that on here that x is just 1. So if x is 1, we'd have 1 plus 2 in the numerator, which is 3. If it was 1, we would have 5. 3 over 5 does not equal 2 over 4 or 1/2. We can't cancel. We can only cancel off if we've factored and gone from there. Okay, let's look at this one. Simplify fully. At this moment, it doesn't look like we can do much. But if we can spot that this is the difference of two squares, we can factor this. So if we've got x squared minus 4, we can factor that to x minus 2 multiplied by x plus 2. So that's a difference of two squares. We'll have now 3 lots of x plus 2. We can see that the x plus 2's are going to cancel, and we can simply write this as x minus 2 over 3. And that would now be our simplified fraction. Difference of two squares, we've gone ahead, factored and simplified. So all of these examples so far are just a case of either cancelling using rules of indices, or just numeric cancelling, or factoring and cancelling off, whether we've got a quadratic factor, linear factors, or the quadratic difference of two squares. Okay, let's have a look at this one here. I've got 24 over 4. 24 divided by 4 is going to give me 6. So I'm certainly going to have 6 in the numerator. I've got x plus 6 all squared. This is x plus 6 multiplied by x plus 6. Generally speaking, I wouldn't write it out in this way, but at the moment we're going to look at it in this way just for this particular example. This 2 is the difference of squares. We could write this now as x plus 6, x minus 6. We can see that the x plus 6's are going to cancel. We've got 1 in the numerator and 1 in the denominator, so that's going to give me 6 lots of x plus 6 over x minus 6. And again, you can bracket this if you wish. So that now is my final answer. Generally speaking, I would have written this now as 6 lots of x plus 6 all squared over x plus 6 multiplied by x minus 6, and then simply cancel the 2 and the x plus 6. The reason being is if that power on the x plus 6 in the numerator was 50, I don't want to be writing out now all of these and just showing that 1 cancels. Let's look at another one. This one, we have a quadratic expression or a quadratic factor in the numerator and also 1 in the denominator. Let's start with the numerator. This we need to factor. This looks like it's going to factor to 2x plus 3, and then we're going to have x plus 1. So this is factoring a quadratic expression when the coefficient of the term in x squared is not 1. If we look at this one right here, we're going to have x, then we're going to have x plus 1. We can see from this that these 2 are going to cancel off. Do check that this is right. 2x squared plus 2x plus 3x plus 3. It often does guide you. So if you're struggling to find a factor of this, have a look down here and see what this is going to do. So what we're going to have then is 2x plus 3 over x. Again, don't be tempted to cancel the x's here. You could write this as 2x over x plus 3 over x, which would give us now 2 plus 3 over x. But if you're asked now for a single simplified fraction, this is what you're going to have. This might come in handy if you're doing some work later on with your studies, but if you're asked for a single simplified fraction, that is what we're looking for. Let's move on and look at something else. Okay, we now have the addition of fractions. So we're asked to simplify fully. The rules remain. If we're adding or subtracting fractions, we need the denominators to be the same. The denominators here are the same. So all I'm going to write now is that this is going to be 2x plus 3x over 7, which gives us 5x over 7. If I can cancel anything here, I'm going to do it, but with this example, we don't have to. Common denominator, we can just go ahead and add the numerators. The same if this was subtraction. We have the same denominator, so we just simply subtract the numerators. So this time we have now a subtraction or a difference. So all we're going to have then is 4x minus 1x over the common denominator now of 5, which is going to give us 3x over 5. So nice and straightforward, common denominator, we're just simply using the skills that we learned lower down the school. Okay, this one now, we've got different denominators. So 2y over 3 and y over 2. So the lowest common multiple of those two is going to be 6. So what I'm going to do is multiply all of this one by 2 and all of this one by 3. The way I like to do this is to write the common denominator. So what we're going to have is the common denominator, and that's going to be 6. I need 2 lots, let's put this on, 2 lots of the 2y, so putting this in, we're going to have 2 lots of the 2y, just grab my pen, 2 lots of the 2y plus 3 lots of the y. So that's going to give me 4y, so 4y plus 3y over 6, which is equal to 7y over 6. If you wanted, you could have written these as equivalent fractions. So we'd need to multiply this one by 2, and that would give me now 4y over 6. And we'd need to multiply this one now by 3, and that would give me 3y over 6. You can go ahead and just go from there. Entirely up to you on how you want to see that. we're going to get 7y over 6 either way round. So this is one approach, this is another approach to write equivalent fractions. But again, just because we've got these y's in here doesn't mean that the rules have changed. If we're adding or subtracting fractions, we need a common denominator. Okay, so this time we've got 2 over x plus 5 over x. Well, we have a common denominator, so it's simply going to be 2 plus 5 over that common denominator, which is going to give us 7 over x. And that is fully simplified. Just because x is in the denominator, it makes no difference. Okay, let's look at this one right here. There are a couple of different approaches. We can write equivalent fractions. If I look, I've got x and 2x. Let's just say that x was equal to 4. So I've got 4 and 8. We know that the lowest common multiple of 4 and 8 is going to be 8. So the lowest common multiple of x and 2x is 2x. For a couple of choices here, we could write an equivalent fraction, which would be 6 over 2x, and add this now to 7 over 2x. That's going to give us now 13 over 2x, so 13 over 2x. Or we could say to ourselves, well, 2x is going to be the common denominator, so we're going to have 2 lots of 3 plus 7. This is another way of looking at it, which gives you the 6 plus 7 over 2x, which is 13 over 2x. So this time, all we have now is a multiple of x in the denominator. Let's have a look at another one. This time we're asked to simplify fully x over 2, and then we're going to have x plus 1 over 3. So with the equivalent fractions, we could write these now as a fraction over 6. So this would be 3x over 6, and this would be 2 lots of x plus 1 over 6. Just being a little careful with this, what we're going to have now is 3x plus 2x plus 2 all over now 6. So that's going to give us 5x plus 2 over 6. Alternatively, you could have written straight away that 6 was the common denominator. We're going to need 3 lots of those, and we're going to add to it 2 lots of those. So this is the alternative to write it like so. Either way round, we're going to end up now with 5x plus 2 over 6. Let's look at this one right here. What we're going to have now is a lowest common multiple of 12. I'm just going to write that as my denominator. I'm going to have 12. I need 3 lots of this one, so I'm going to have 3 lots of x minus 3. Then I'm going to have 4 lots of x plus 1. So if we think about this now, expanding now the numerator, we'll have 3x minus 9 plus 4x plus 4, and that will be over 12. Do be careful if you have negatives in here. Just make sure you're on top of your rules of adding and subtracting negative numbers. So we're going to have 7x in the numerator minus 5, all now over 12. So that is simplified. Again, you could write equivalent fractions with this and write this one over 12 and then add from there. Okay, this time now we have x plus 1 in the denominator. So 2 over x plus 1 plus 5 over x minus 4. The common denominator is going to be now the product or multiple of these two. The way I like to do this is as follows. We're going to have x plus 1, x minus 4. And I say to myself, what do I need to multiply this fraction by to get the common denominator? And it's the x minus 4. So we're going to have 2 lots of x minus 4. What do I need to multiply this fraction by to get the common denominator? And it's the x plus 1. So we're going to have 5, then we'll have x plus 1. So that's going to give me 2x plus 5x, which is going to give me 7x. Minus 8 plus 5 is minus 3. And then we're going to have that over, and not expanding this, just leaving it now as the product of these two linear factors. That is my final answer. Again, you could have done the same here. You could have written that this was going to be 2, then we'd have x minus 4 over now x plus 1 multiplied by x minus 4, and then we would have had 5 x plus 1 over now the x plus 1 multiplied by x minus 4. I prefer this approach and to look at what each term is missing from the lowest common multiple. Let's look at another one. Right, this one is slightly trickier. We got 3 over x plus 1 minus 4 over x squared minus 1. This again is the difference of two squares. So what I'm going to do is write that this is going to be 3 over x plus 1. That is one linear factor. So linear just means that we have x to the first power. 4 over, and factoring this, x plus 1, x minus 1. That means that the lowest common multiple, or the common denominator of this fraction, is going to be now the x plus 1. So x plus 1 multiplied by x minus 1. That's the lowest common multiple of those. So what we're going to do is simply write now that this will be 3, then we'll have x minus 1 minus 4, and of course we are not missing anything from the common denominator. Just think about writing an equivalent fraction. An equivalent fraction now is this. So x plus 1, and then we're going to have x minus 1. That is the equivalent fraction. So we have 4 over x plus 1, and then x minus 1. So if we just look at this, we're going to have 3x minus 3 minus 4. So we'll have 3x minus 7. And I'm going to write this back now as x squared minus 1. So this is now a single simplified fraction. So it's entirely up to you. If you want to consistently write out equivalent fractions, you can do. Or you can say to yourself, what was I missing from the common denominator here, and we multiply up. Let's look at another one. Okay, this one is incredibly challenging. We've got 1 over x plus 4 over 3 lots of x plus 1 plus 2 over x plus 2. The lowest common multiple, or the common denominator, is going to be the product of each of these. So, for example, now if we had x plus 1 squared, we would have now a lowest common multiple of x multiplied by 3 multiplied by x plus 1 all squared. Let's just look now at the lowest common multiple. It's going to be now x, and I'll write this as 3 lots of x plus 1 multiplied by x plus 2 multiplied by x. I appreciate, in fact, I'll write it as it goes, just to make this slightly easier. But essentially, right, let's just clear that and we'll do it from here. It's just now the lowest common multiple is the product of these 3. So I'm going to have x multiplied now by 3 multiplied by x plus 1 multiplied by x plus 2. None of these are common, so this is the lowest common multiple. What I like to say to myself is, what was I missing from this fraction that I now have in the denominator? The answer is now 3 lots of x plus 1 and then the x plus 2. So what I'm going to have is 1, then we're going to multiply this by 3 lots of x plus 1, and then we're going to multiply that by x plus 2. That was what I was missing in terms of the first term. If I look at the middle term, I'm missing the x and the x plus 2. So we're going to have 4 multiplied by x multiplied by x plus 2. And then finally, what was I missing here? Well, it's the x and the 3 lots of x plus 1. So I'm going to have plus 2, I'm going to have the x, then I'm going to have 3 lots of x plus 1. So I've now got to expand all of this, and it's going to be quite a mess. So if we look at this, we're going to have 3 lots of x squared plus 3x plus 2. Plus now, if I expand this one, we're going to have 4 lots of x squared plus 2x. If I go ahead and expand this one, we're going to have two lots of now x, so it's going to be 3x multiplied by now the other factor, which is going to be the x plus 1. So you can see that we're going to have lots and lots of tidying. It's highly unlikely that you would get this in an exam, but I think it's interesting nonetheless. So let's go ahead and look at that. So what are we going to have in our denominator? We're going to have, and I'm going to write it as 3x, then we're going to have x plus 1, and then we're going to have x plus 2. So if we now tidy this numerator up, we're going to, and I'll go through this and just do it fairly quickly. What I'm going to do is terms in x squared. So I'm going to have 3x squared. I'm going to have plus 4x squared. I'm going to have now plus 6x squared. So they're my terms in x squared. As stated, it's highly unlikely you would get this in an exam, hence why I'm not spending a massive amount of time doing it. I suppose we can see this as an extension. If we now look at terms in x, I'm going to have 9x, so plus 9x. I'm going to have plus 8x. And then on this one, I'm going to end up with plus 6x. If you want to expand this the normal way, you certainly can do. And then if we look at any constants now, we're going to have, when we talk about constants, their terms about x. 3 times by 2 is going to give me 6. And on this one, we're not going to have any because we're just going to have 8x. And then we're going to have now the 6x. So plus 6. And that's all over now the common denominator. So let's go ahead and do that. The common denominator of 3x, x plus 1, and then x plus 2. So let's go ahead and do that. What have we got? We got 13x squared, so 13x squared, plus now 23x, plus 6, all over now 3x. Then we're going to have x plus 1, and then we're going to have now x plus 2. So there we go. I'm not going to see if this one factors. Just looking at it, I'm not going to even try. But if you want to find out whether this is correct, what we could do now is just let x be equal to 1 and see that it has the same value. So if we said that x is equal to 1, that's 1 over 1, which is 1, plus now on here 4 over 6. So I'm letting x be equal to 1, 4 over 6, and then we've got plus 2 over 3. So just letting x be equal to 1 in all of those, that's going to give me now 7/3. So if we just write this down, if x is equal to 1, and just checking I've done all of this right, if x is equal to 1, so x is equal to 1, the answer to subbing that in is going to give me 7/3. Let's see what we would get if we put it in here, and just checking now. Hopefully this will work, hopefully my algebra. So we'd have 13 lots in, let's put it in here. We'd have 13 lots of 1, plus now 23 lots of 1, plus 6, over now 3 times by 1, times by 2, so times by 2, times by another, that's going to give me 3, and that should give me the 7/3. So we can see that it has the same numeric value. So hopefully all my algebra is held up well, and we've gone through that. So that's one way of doing that one. So what we've looked at on these is looking at factoring, simplifying, and then just using our basic rules. So the last one was an extension. This one is probably an A star, more realistic. So what we've got now is 2 over x squared plus 2x minus 8 minus 3 over x squared minus 16. What I'm going to do is look to factor. So if I factor the denominator, this is going to be x plus 4 multiplied by x minus 2. I'm now going to subtract from that, and I can see again I've got a difference of squares. That's going to be x plus 4, and then we're going to have x minus 4. What we need is the lowest common multiple. We can see that x plus 4 appears in both. That's going to give me, and I'll write it just up here, that's going to give me a lowest common multiple of x plus 4 multiplied by x minus 2 multiplied by x minus 4. So that is our common denominator. So we're going to have x plus 4 in any order, then we're going to have x minus 2, and we're going to have x minus 4. So if I look now from this fraction I'm missing here the x minus 4. So I'm going to write this now as 2 lots of x minus 4. Minus, and from this fraction in the common denominator, I'm missing now the x minus 2. So x minus 2. So I can write it like so. So we're going to have now in the numerator, we're going to have 2x minus 8, be careful here, minus 3x plus 6, all over now our common denominator of x plus 4 multiplied by x minus 2 multiplied by x minus 4. If we look here, we're going to have minus x, and then we're going to have minus 2, and that is going to be written now over. And we can write this back as x minus 2, if we like, multiplied by x squared minus 16. If you want, you could tidy this up. We can't cancel off, but we could write this as minus x plus 2 over x minus 2 multiplied by x squared minus 16. Again, if you want to check, letting x be equal to 1 and see that this holds, you will see that that is going to be the case. At this stage here, I've gone and written it like so. What you could have done at this stage is said, well, what I'm going to do is write an equivalent fraction. So the equivalent fraction is going to be multiplying up. We're going to have 2 lots of x minus 4 over x plus 4 multiplied by x minus 2 multiplied by x minus 4. And then I'm going to subtract from that the equivalent fraction, and writing it now the equivalent fraction here, this is going to be now the x minus 2. We're going to have the x plus 4, and as stated, it doesn't matter which order these in, so we can write these in like so, and we need to now multiply the numerator by the x minus 2 as we multiplied the denominator by the x minus 2. So again, a very tough example there, but hopefully that gives you some idea. So that again is factoring and going ahead and simplifying fully by finding a common denominator. So there we go. That is looking at the basic simplifying of fractions through cancelling. It's looking at factoring and cancelling. Then it's looking at adding and subtracting algebraic fractions. The last two were really quite tough, and don't penalise yourself too much if you were a bit bewildered. Certainly the course that you'll move on to after this will look at those in more depth, but hopefully that's given you enough information to move forward.